I guess I'm curious, like, what is the scale of data that we're actually going to need? Like, where do we get this data? What is the nature of this data? What is the maybe like what is the ratio of the simulation versus the actual data we're going to need? And how does that kind of play into what you think the timeline will be for when we'll actually see humanoid robots or embodied robots?
Uh, yeah, I think to do useful things with humanoids, we have everything we need today. Like that's already true. I don't think that we need to sort of go through this huge data scaling process to get to minimally useful. I think that that's more again the computer science. Like how do we solve this very abstract task in a very general way? There's a inclination there to do everything all at once, and so we want all of this data to solve the general task, but that's not what required to do useful work. We can already do that with the approaches that we have now. And so I think there's a couple of different ideas here. So one is the simulation versus real data divide. You know, how much data is sufficient, and where does it need to come from? Um, I think that compared to language modeling, where we had to have all of this reference data because we didn't have a text generator, we're trying to train the text generator. Robotics is kind of nice because we have the laws of physics, and so it's very easy for us to simulate what is happening in the real world to a point, right? There's certainly a level where very very granular, maybe fluid dynamics that's harder to do, but certainly for rigid body dynamics, we can do it at scale already. The simulation is already getting us there. To the point where I don't use any real data whatsoever when I train my robots. Everything is being done in simulation and it transfers to the real world just fine.